What's up guys, and welcome to this tutorial. This is probably going to be the last question that I do. So we are still going over Root Locus, and we are going to go over one last example, which is similar to the last one, but not really, and it's going to cover all the guides. So let's get straight into this example. Okay, so basically we have a closed control system which has the following open loop system: G of S H of S, which is equal to K over S squared plus 5S plus 8. Okay, so we need to get it into the format that we want it to be in. So what we have is the characteristic equation format, which is 1 plus k times 1 over. Okay, so we can try factorize this, 1, 5, and 8, trying to factorize that, but it doesn't give us a real solution, so we're just going to have to leave it the way that it is. S squared plus 5s plus 8. Okay, so we're going to have to keep it in that format, and we make that equation equal to 0. Okay, now we know that guide 1 tells us that the root locus is symmetrical, so we don't care too much about that. So we go straight to guide 2, and guide 2 we deal with the zeros. So there are no zeros, so there's nothing in the numerator, so we can say there are no zeros. Therefore Z is equal to 0. And if we look at the poles, we have S is equal to 0, or S is equal to minus 2 plus, minus 2 comma 5 plus 1 comma 3 to 9. Let's stop it there. Or S is equal to minus 2 comma 5 minus 1 comma 3 to 9i. Okay, so we have our conjugate pair, and therefore P is equal to, we have 1, 2, 3 solutions, so P is equal to 3. Then we go P minus Z, which is 3 minus 0, which is obviously 3. Okay, so from this, what we can say is using guide number 3, using guide 3, we can say we have 3 poles and no zeros. Therefore, all the poles go to infinity. Okay, so now let's get out our nice sketch. Let's get some axes. Okay, it would be better if we could have it right there. Okay, so we can draw a nice set of axes. Okay, something like that, and we're going to space them out. 2 of these blocks equal 1 unit, just like normal, same spacing on both set of axes. Okay, so now that we have that sorted, let us go and put in our poles and our zeros. Okay, so we have no zeros off of the get-go, and we have poles at the point 0, so that would be this point right here, and at the point minus 2.5 and plus 1 comma 3. So minus 2.5, so 2.5 is right here, and 1 just less than 1.5. So we have cross right there, 2.5 and just less than 1.5, let's say there. Okay, so using guide 4, remember when we're numbering these, this is going to, there's only one pole or zero in this case, pole. There's only one pole on the real axis, so therefore we have an odd number, so we have to take this one all the way to infinity. Okay, so that so that has to go to infinity. If we had another one, let's say we had another zero or pole on the actual axis, then we could have stopped it there, but we don't. Therefore, that goes to infinity, okay? So we can continue to guide number 5. And guide number 5 is used, let's see, what was guide number 5? Okay, to find out breakaway points. Okay, so the breakaway points are at dk ds is equal to 0. So we start off with our equation that we have, which is 1 plus k over 1 over s squared plus 5s plus 8 is equal to 0. So therefore k is equal to minus, taking that, let's say that's s cubed plus 5s squared plus 8s. Okay, multiplying that in. And then we can take the derivative, dk ds is equal to, let's keep the minus right there, and we're going to say that's equal to 3s squared plus 10s plus 8, which is equal to 0. I'm going to equate that to 0, so we can remove that minus sign, and we're left with 3s squared plus 10s plus 8 is equal to 0. Okay, now we can just plug this into our calculators to see what s is equal to. So s is equal to minus 1,333, or s is equal to minus 2. Okay, so what do we know about these, right? So we need all of these three to end at infinity. All these zeros have to end at infinity. So according to this, we are going to have a breakaway point as well as these two breaking into the system. Okay, so we're going to have a breakaway point and a break-in point. Okay, so the break-in will most likely take place with the two in the imaginary plane as well. So that will take place at minus 2. So this is actually a break-in point, and this would be a breakaway point. Okay, so it would be useful to get the values of k. Okay, so let's just mark this out. So break in at minus 2 is right there, and minus 1 1/3, so somewhere around here we expect them to break into the system, break away from the system. Okay, so let us now get the value of k. Okay, so k at s equals minus 1,333. So we're just going to substitute 1,333 into that equation right there. So let's do that. Minus 4 over 3 is minus 1.333. So we're going to have minus s cubed plus 5s squared plus 8s, and that equals 4,1481, and at k, where s equals minus 2, so we substitute minus 2, and when we plug that in, we get k equals 4. Okay, so those are the most important points that we have, so let's put a box around that right there. Okay, so now we can go on to guide 6. Okay, so guide 6 has to now do with our asymptotes. Okay, so which equation are we going to use? Let us go and see. We've got two options. It doesn't really matter which one. Let's pick the second one. So theta, this one right here, theta equals 2k plus 1 over p minus z. So theta equals 2k plus 1 over p minus z times 180 degrees. Okay, where k equals 0, 1, 2, ... p minus z minus 1. Okay, so we already know that p minus z is 3, so p minus z minus 1 is 2. So this is equal to 2, therefore k equals 0, 1, and 2. Okay, so now we can get our thetas. Okay, so the first one we substitute 0, so that's going to be 1 over 3 p minus z, p minus z is 3, times 180 degrees is 60 degrees. Okay, so next we substitute 1, so that's going to be 2 plus 1 over 3 times 180 degrees, which is equal to 180 degrees. And next we substitute 2, so that's going to be 4 plus 1 divided by 3, so that is 300 degrees. Okay, so those are the angles at which it breaks away. This is coincidentally minus 60 degrees also. So if we were to draw it on our nice axes quickly, so 60 degrees is somewhere around there, 180 degrees is somewhere around, no, that's exactly around that line, and minus 60 or 300 degrees is like that. Okay, so that's what we expect our asymptotes to look like. Now we just need to figure out where the centroid of our asymptote is. So we go into guide 7. And guide 7 says that the centroid is equal to the sum of the s values of the poles minus the sum of the s values of the zeros all over the poles minus the zeros. So that's over 3. And the sum of the poles is, okay, and we only consider the real parts here, only the real parts. So it's going to be 0 minus 2.5 minus 2.5. 0 minus 2.5 minus 2.5 minus 0 essentially, because there is no there are no zeros. So therefore we get minus 1,6667. Okay, so that is where our centroid of the asymptote exists. So let's go and put in our asymptotes. So minus 1,66. So this is 1.5, 1.66, let's say, is right here. Okay, so along that we have 180 degrees, so that's along this line, which you can't really see. Okay, but it's along there. At 60 degrees, so again, you're supposed to use a, let's say, a compass and a protractor to get your nice 60 degrees so that it's accurate. Unfortunately, I don't have that available in the software. So I am just going to try freehand it. Okay, so you should be able to get a general idea of what this looks like. Okay, there we go. So let's also just label that. Might get a bit messy here, but that is 60 degrees. That is minus 60 degrees. Okay, now we need to find. Okay, obviously this is now going to look something like that. It's going to break through the, it's going to cross that axis and go to infinity along that asymptote. So now we need to figure out where that happens, and that to do that we use guide number 5. Sorry, not guide number 5, but guide number 8. Okay, so using guide number 8, we let S equal to I omega, and let's see which equation we're going to use. Let us use this equation right here, okay, where we say K is equal to minus S cubed plus 5S squared plus 8S. Okay, so using that now, let's substitute I omega, so K equals minus I omega cubed plus 5, actually we're taking that minus in, minus I omega squared minus 8 I omega. Okay, now what we're going to do is we're going to equate reals and imaginary. Okay, so the reals, we're going to be, okay, let's actually expand this out. So I'm going to give myself a little bit of space. Let's expand this. This is going to be K equals minus, okay, so I cubed is minus I, so that becomes a positive I omega cubed. Okay, I squared is minus 1, so that becomes plus 5 omega squared minus 8 I omega. So the reals would be K is equal to 5 omega squared. Okay, that's sorted. Now we look at the imaginary, and we can say 0 is equal to omega cubed minus 8 omega. Okay, so we can say 0 equals omega squared minus 8. Therefore, omega equals 0, which we don't care about, or omega equals, we only care about the positive value, so we're going to say the square root of 8. Obviously, it is plus or minus omega, but we deal with that when we're plotting. So square root of 8, and if we plug that into this equation right here, we can say that k equals 5 times the square root of 8 squared, which is just 5 times 8, which is equal to 40. So k equals 40, and we let s equals I omega, so that means s is equal to I times the square root of 8, which is equal to 2,8284i. Okay, so this is the most important part of this part of the question. Okay, and now we can go plotting. Okay, so the point is 2,82 or 2,83. Let's go find that point. 2,5. Let's say 2,8 is somewhere here, and similarly minus 2,8 will be somewhere here. So now what we have is these break in points, so we're going to start from here, and we're going to go in, and we're going to go in like that. Okay, so that's what one of them looks like. This goes off to infinity, and what we're going to have is at this breakaway point, it's going to break away and go towards that point right there, and it's going to break away and go like that. Okay, so that's what our graph is going to look like. So yeah, basically there's three of them, so let's actually change the color quickly, and basically it goes in three directions. So let's say this breakaway point would actually go like this into there and then go along that direction, which would be one of them. The second one would break in here, then go either upwards or downwards. Let's say it went downwards. We don't actually know this. It would go that way. And the pink one, let's do it in, let's switch colors quickly to blue. Okay, this one right here would go like this and would go right like that. So those are the three paths that we actually have. So I've done them in three different colors, blue, purple, and gray. But let's just clean that up again to how it was. So it looks a bit cleaner, but that's what you'd be expected to do. Now let's just go and label these points. So this point here is where k equals 40. This is also k equals 40. And what is the value there? Was 2,828. S equals 2,828i. And over here it's s equals minus 2,828i. Okay, once again, you should probably label these points as well, which we calculated. I'm a bit tight on space, so I'm just going to leave it, but you would put these values in. Okay, so minus 1,333 with k equals 4,1481. Okay, but yeah, this is quite a nice example. Lots of things happening, and it's nice to be able to go through the guides and use every single one. So thanks for watching, guys. This will probably be the last video. If you want more, you may request some, but yeah, thanks for watching, and I hope you found this series useful.